Good day to all. I am Dr. Kannan, professor in the Department of Computer Science and Engineering in Bharat Institute of Higher Education and Research. Today I am going to teach about the basics of Internet of Things. In this course, we are going to learn about what is maybe Internet of Things and what are the characteristics of IoT and how we can design the IoT. We can design the IoT used by logical design and the physical design of IoT. And also we're going to be say about the application of IoT and different levels of the IoT. So first thing is what is maybe IoT? Those days the peoples are connected to the internet. So we used to say that internet of peoples. Once the technologies are evolving, we know that all the things are connected to the internet. Then we call it as an internet of things. First of all, we should know about what is maybe things. So things is nothing but the physical object. So that physical object will be connected to the internet, which enables the object to collect the data and exchange the data. That is what we call as an Internet of Things. So we can see the definition for the Internet of Things is the network of physical object or things embedded with the electronics and software as well as the sensor. So the main part for the Internet of Things, so we need the sensor. So the sensor only will be collecting the data. After collecting the data, it will be sent to the cloud or maybe any storage media. How it will be sent to the cloud or maybe the storage media? By using the network connectivity. You have to use the different network connectivity like Wi-Fi or maybe the Bluetooth. Okay. So in this case, with all these objects or enables the objects to collect and exchange the data. Okay, so then IoT is an ecosystem of connected physical objects. Okay? And also this object to be sensed and controlled by remotely. Okay, so the objects to be sensed and controlled remotely across the existing network infrastructures. So we maybe use the any kind of network infrastructures. Maybe we can use the local area network or maybe using the wide area network. Okay. So for using the network infrastructures, we have to creating the opportunities for more direct integrations between the physical world and the computer-based systems. Okay. So why we are connecting this kind of computer-based systems is this, so we have to be improve the efficiency as well as the accuracy and also in terms of the economic benefit. Okay. So from this one, we are going to be connect the things. So the things is nothing but the physical objects or the things embedded with the electronics. For example, we want to be connect our fridge or maybe the washing machines, your fridge or maybe the washing machines. So these things we are going to be connected to the internet and we are going to be control all the operations as well. Let's say, for example, if we have in our home, we need to perform the automations. So let's say, for example, say in the light, we need to be controlled through the IoT. How it will be happening? So we need to be connect the sensors to the fan, and this sensor will be sense the data when the fan is rotating or when the fan is not rotating. So this data will be sent to. Okay, so once the sensor collecting the data from the fan, it will be sent to the cloud or to the any storage media. So from that storage media, we will be processing the data. And once if you are processing the data, we can be exchanging the data. Okay, so this is what we call as the IoT Internet of Things. So now we are going to say about the characteristics of the IoT. So we have the different characteristics of IoT. So the first characteristics is the connectivity, and the second characteristic is the intelligence, and the third characteristics is the scalability, and the fourth characteristics is the unique identity. Okay. So first of all, what is will be connectivity? If you want to develop any IoT application, means we need the connectivity, network connectivity. It may be either the Wi-Fi connections as well, or maybe the local area network, or maybe the wide area network, or maybe you can use the Bluetooth also. Okay. So this here, the connectivity, the things in the IoT, it should be connected to the infrastructures. So without a connections, nothing make sense as us. So we need things. If you want to be connect, if I want to connect the things to be internet means as us, we need the connectivity, network connectivity. If there is no network connectivity, means we cannot able to connect the things in the internet or in the networks. Okay. So then next characteristics is the intelligence. So what is going to be intelligent means is that we have to be extract the knowledge from the generated data. So let's say, for example, the sensor will be sends the data, which means reads the data. The data need to be very important, and the data should be interpreted properly. So we have to be analyze the data properly. Okay, that is the second characteristics of intelligence. Then the another characteristics of IoT is the scalability. So we already know about in the computer network, we have the scalability, which means that we can be attached to more than one device or any number of devices we can be attached on the network. So that's we call it as in the scalability, network scalability. Okay, so similar here in the IoT also, we can make the scalability, which means that things get connected to the IoT will be increasing day by day. Okay, so what will happen in them? The IoT setup shall be to handle the massive expansions. So this is what we call as the scalability. Then another characteristics is the unique identity. So what is going to be the unique identity? Identity means each IoT devices, it has the unique identity, which means a unique IP addresses. Let's say, for example, any devices we're going to connect to the internet. So that device has the IP addresses. Okay? And also it will be integrated into the information network. And what's the purpose of the IP addresses? So normally we have to be allowed to communicate and exchange the data with the other devices. So these are the main characteristics of the IoT. The first thing is the connectivity, and second thing is the intelligence, and third one is the scalability, and the fourth one is the unique identity. Then fifth one is the integrated into the information network here. Okay. Then how the IoT works as well. Okay, so how the IoT works. So we should know about we need to know about the how does the IoT will be working. That's the basic principles. You see this the figure shows that how does the IoT will be works. So first thing is we need the sensor. A sensor or maybe the IoT device. IoT device is nothing but is a sensor. So for here, this sensor is the devices or maybe the key component. Will be the devices or be the key components that helps you to collect the data from surrounding the environment. For example, say if you have if I want to know about the room temperatures. So in this case, I need to be plot or I need to be place the temperature sensor, let's say THT11. So this sensor will be collecting all the temperatures, room temperatures. Then once if you are collecting the data from the sensor or from the devices, we need to send the data to any kind of storage media. Either you can be stored in the local storage or maybe you can store in the cloud storage. So in these cases, we need the connectivity. We need the connectivity. So all the collected data, is sent to the cloud infrastructures. So once if you're sent to the cloud infrastructures, okay, so we have to be use the different kinds of communication mediums like mobile communications or mobile network or maybe the satellite communications or maybe you can use the Bluetooth or maybe using the Wi-Fi, or maybe using the wide area and network. Okay, so this is the second thing is a very important one, that will be connectivity. Then another thing is the data processing. So once if the data is stored in the any kind of storage media, it may be either the cloud or maybe either the local storage medium. So that one we have to be processing the data. So we want to process the data. How we need to be processing the data means we need a set of software. Normally, if you want to do processing any data means definitely we need the software. So that software performs the processing on the gathered data and also identifying the objects, maybe using the computer visions on the video. So the most popular the software we can be used for the programming languages and Python. So that we develop the IoT applications using the Python. Using the Python programming, we can develop the all kind of IoT applications as well. Okay. Then also after the data processing, we have to do the user interfaces as, which means that the user can interact with the system very easily. Let's say, for example, I am in the office. Okay, I forgot to switch off my fan in my home. So in these cases, I need to be switch off my fan through my mobile devices as well. Okay, in these cases, we need the interfaces as well. I need some applications as well. Okay, so how we can develop the applications? We can develop the applications by using the user interface. User interface means the user can interact with the system very easily. Okay, so for here, the information needs to be available to the end user in some way, which can be achieved or by triggering the alarms on their phones. Maybe we can generate the triggering by generating the using the alarms or maybe sending the messages to one phone. Okay, let's say for example, I told you if you are forgetting the switch of the fan in your home, so maybe the message will be generating to your mobile phone. You have forgot to switch off the phone through the interfaces. So in this case, what we are going to do, we are going to immediately switch off our fan. Okay. So this is the how the IoT will be works as this. So for example, this is the diagrammatic representation of you see the here things are all connected. Maybe the printer, or maybe the home, or maybe the camera. So these are all of the speaker. These are all of the things as this. So these things as this will be connected to the internet. Okay, and we are designing the user interfaces as maybe I want to switch on the printer. So using that interfaces, I am going to switch on the printer, or I want to print some documents as well. I want to print some documents to the printer. So this is using how going to be used. We're going to using the user interface. So this is the way what IoT works. For example, using the sensor, or maybe the connectivity, or maybe the data processing, or maybe the user interfaces. Okay. Now we are going to see about how we can design the IoT. So normally the main thing is we need to design the IoT. So basically, if you want to design the IoT means this, we can be designed with the IoT. There will be two ways we can be designed the IoT. One is the physical design of IoT. Then another one is the logical design of the IoT. Okay, so one is the physical design of the IoT, then another one is the logical design of the IoT. So before we go to see about the physical design of IoT, as we just know about what is the IoT, we already know about that. The IoT devices which can perform remote sensing, or maybe the actuatings, or maybe the monitoring the capabilities. And the devices, the IoT devices will be exchange the data with the other connected devices, and also maybe the applications. It may be either directly or maybe the indirectly. Okay, and they collected the data from the other devices and process the data locally. Okay, so this is the way the IoT device can do that one. Then this is the generic block diagram of an IoT. Okay, generic block diagram of the IoT devices. So normally the IoT devices, it has the several interfaces. So for example, we having the Raspberry Kit. So it's the most popular IoT device. So that the Raspberry Kit, it having the connectivity, and it having the processor. For example, so that having the CPU, the Raspberry Kit is having the the CPU, that's having the central processing unit, and also it is having the connectivity. So the connectivity means this, we have to do that either we can do the connectivity in the USBs, okay. Then we have the memory interfaces as well. So the memory interfaces means so we are going to connect the memory users, maybe use the NAND or maybe the DDR RAM like that. Okay. Then we have the input output interfaces as we need to be connected our keyboard or maybe the mouses or maybe the Ethernet. We can be connected to the input output interface. And main thing is we can be connected the sensor. Okay, we can be connected the sensor, and also the actuators also we can be connected. This is the generic block diagram of the IoT devices. So now we are going to see about the logical design of the IoT. Logical design of an IoT. So what's the logical design of the IoT means? It represents, first of all, we should know about what is a logical design of an IoT systems. So normally it refers to the representation of entities. Okay, so we have the entities. Entity means this, it is an object. Maybe it is having any object. So that objects will be processed without going into the low-level specifications. Going into the low-level specifications. So in this case, how we can be designed the logical design of IoT. So we have in there are three blocks, or there are three ways we can be design the logical design of IoT. One thing is the IoT function blocks. Okay, one is the IoT function block. Then another one is the IoT communication models. Okay, one is the IoT function block. Then another one is the IoT communication model. Then another thing is the IoT communication APA. There's an application programming interfaces. So these are the three things as we can be designed or comes under the logical design of one IoT. Okay, so first thing is the first design is the IoT function block. Okay, so the first thing is the IoT function block. So this is the diagrammatic representation of the IoT function block. Let's say, for example, sir, it has the devices as well. Okay, the lower blocks as in the IoT, it has the devices. Then the next two is having the communication. Then the another blocks having the services. Then having the management. Then we having the application. Then last one having the security. Okay, so first of all, what is the device blocks as okay? So the device means this it having the different devices as so you're going to be using the moisture sensor, or maybe using the temperature sensor, or you may be using the gyroscope sensor. Okay, so what is the use of that sensor means this? It will be sensing the data, which means it will be read the data, and also it will be do the actuation. It means it will do some processing. Okay. After processing the data from the devices, after the data processing from the devices, it will be sensed. So how will be sensed? We need to be handling some communications as well. So I already said that before slides. The communications we can be use the any kind of communications. Maybe you are using the Wi-Fi, or maybe using the Bluetooth, or maybe using the satellite communication, or maybe you are using the mobile communications with us. Okay, so the next blocks is us, it having the services. So in that services, what is the use of that services? We have to for the device monitoring. Okay, so we want to monitor the device, whether the device is working or not working. And once if you are monitoring the devices, we have to be control the devices as, which is I told you, I want to switch on the light or maybe switch off the light. This is the services I can do on the devices as well. Okay, and after that we can do the data publishing services as well. So we need to be publish the services, and for the service for the device need to be a discovery. Okay, so this is what we call as that blocks are in the service block. After that we have in the management. So we need to provide the various functions as well. So to perform the IoT systems, okay, we have to perform the different various functions to perform the IoT system. And also we have the security. So of course we need to the security of IoT system is a very important one. to which means that which person we need to be authenticate and authorization, okay, and also the message and the context integrity as well as the data security. Okay, so this is what we call as the security one. Then the last one thing is the applications. So in that applications, the IoT applications, it provides the interfaces that the user can use to control. Okay, the user can use to control and monitor the various aspects of the IoT systems. Okay, the user can use to control and monitor the various aspects of the IoT system. So this is totally we call as in the IoT function block. Okay. So then the next logical design of the IoT is the IoT communication model. Okay, so the next model will be the IoT communications model. So in that IoT communication model, we having the request response model. Okay, we having the request response model, and we having the publish subscribe communication model. Then another model will be the push-pull model. Then another model will be the exclusive pair model. Okay, so these are the different kind of communication model in the IoT. Okay, so the first thing is the request response model. Then the second thing is the publish subscribe communication model. Then third one is the push-pull model, and the fourth one is the exclusive pair model. Okay, so now we are going to see about that what is mean by the request response communication model. Okay, so what is mean by the request response communication model? So the request response communication model is similar to like our client and server model. So you all familiar with the client and server model, which means this whenever the client sends the request, okay, whenever the client sends the request, so the server will be accept the request. Okay, so the client sends the request to the server. The server will be accept the request and it will be sent to response for the particular client. So let's say, for example, I'm Googling the books. I want to know about the basics of Internet of Things. Okay, so that's what I'm going to do. I'm going to search the, I'm typing the basics of Internet of Things. Okay, so I'm the client. So I'm searching using the Google search engine. I'm searching the Google search engine. So for the Google search engines, what I'm going to type, I'm going to type the basics of Internet of Things books. So what will happen in them? The server will be accept the request. Okay, the server will be accept the request. So what the server immediately fetches the data from the resources. Okay, so let's say maybe the books for the Internet of Things is this, maybe the Bhagavad, something like that. Okay, so what will happen in them? It will be the server will be fetches the resources, okay, and prepares the response and send the response to the client. Okay, so this is what we call as the request response communication model. So request response communication model is the way in which the client sends the request to the server responds to the request. Okay, so how does the server will be response to the request means is this, it will be retrieve the resource representation. You see here, this is the resources. So let's say if you want to retrieve some information from the Google search engines, so what will happen in them? So the server will be immediately fetch the particular resources, okay, and prepare the responses, then sends the response to the client. So this is what we call as a request response communication model. Okay, so the request response communication model is a similar like our client and server model. Okay, then the next communication model will be the publish subscribe communication model. So what is going to be the publish subscribe communication model? So here it involves three users only. The first having the publisher, there will be a publisher, and there will be a broker, and there will be a consumer. So there are three users are involving, okay, in the publish the subscribe communication model. Okay, so in that publish subscribe communication model, there are three users are involved. One is the publisher, then another one is the broker, then another one is the consumer. Okay, so what about the publisher means is this, so the publisher are the sources of the data. Okay, so what will happen in them? It will send the data to the topics which is managed by the broker. So the here The queues are the broker one, or nothing but it will be the queues. Okay. So then consumer, it will be subscribed to the topics which are managed by the publishers. But the publisher are not aware of the consumers. Okay. So this is the what we call as the publish subscribe communication model. Okay. Then the another model in the IoT communication model is these models are comes under the, I already said that these models are comes under the logical design of an IoT. Okay. So the next model is the push-pull communication model. Okay. So the push-pull communication model also it will be similar to the our publisher subscribe communication model. So here in the push-pull communication model, the data producers, the data producer, it will push the data to the queue. Okay, so the producer or the producer push the data to the queues, and the consumer will pull the data from the queues of us. Okay, but the producers that they doesn't aware of the queues. Okay, they does not aware of the consumers. Okay, so for here in these cases, the queue will also act as the buffer, which helps in the situation as. So when the situation will be occur means when there is a mismatch between the rate at which the producer will push the data and the rate at which the consumer will pull the data. Okay, so this can be maintained by the queue. So this model we call as the push-pull communication model. Then the another model will be the exclusive pair communication model. The exclusive pair communication model. So this exclusive pair communication model is a bidirectional one, as well as the full duplex communications. As we all know, what the full duplex communication means that both the sender and the receiver can send the data at the same time as well. That is what we call as full duplex communications. Because the communications is that we can be categorized as how the data can be, how the message can be transmitted. Okay, either the source can only send, but the receiver can receive. Okay, but the receiver can listen. But at the same time, the receiver can send the data, the sender may be the receiving that one. Okay, but the full duplex communication model is the both the sender and the receiver can send the data at the same times. Okay, so it uses the persistence connections between the client and the servers. So for here, how we can be establish the connections as well? How we can be establish the connections? So first of all, the client sends the request to the servers. We need to establish the connections. We need to establish the connections between the client and the servers. We need to establish the client. We need to establish the connections between the client and the servers. So for what case? In this case, the client sends the request to set up the connections. So here see the diagrammatic representation. The first thing is the client sends the request to the set up connections. So the server will be accept the request, and immediately it will be response the accepting the request. Okay, the server will be response accepting the request. So once if the connection is established, okay, once if the connection is established, so the message from client to servers, the messages from client to servers, and the messages from, we can be transfer the messages from the server to the client. Okay, so once if you are transferring the messages, or once if the message is communicated between the client and servers, okay, then the client sends the connection request. The client sends the connection close request. Connection close request. So after that, once the server will be accept the connection close request, and it sends the connection close response. This is what we call as an exclusive pair communication model. So exclusive pair communication model means that it similar looks like our client and server model, but here before the messages, before the client wants to send the message to the server, it need to establish the connections. Okay, it needs to establish the connection. How it to be established the connection means it will be sends the request to the server. Based on the request from the client, the server will be responsive for the request. Then after that, they can be transferred, the message will be transferred from client to the server. then from server to the client. Then what will happen, after communicating the messages between the client and the servers, we need to be connection close request. Okay, so that is called as an exclusive pair communication model. Okay, so then another model is the IoT Communication APA. So in previous slides I said that we can be design the logical design of the IoT. There are two ways we can design of the IoT. One way is the logical design, another one is the physical design. In that logical designs, we have in the three things as three design we can be able to design the IoT. First thing is the function block, and another one is the communication model. Then we have in the another thing is the communication APA. Okay, so now we're going to see about the IoT communication APA. Okay, now we are going to see about the IoT communication APA. Okay, so what's the IoT communication APA means is this? The first thing is we're going to see about that the REST-based communication APA. So the REST-based communications APA, we call this one request response based model. Okay, request response based models. That is what we call as REST-based communication APA. And also the another model will be having the web-based communication APA, that is called as an exclusive pair-based model. There are two models of this. So one is the REST-based communication APA. Then another one is the WebSocket-based communication APA, that is called as an exclusive pair-based model. So the first model is what is going to be the REST-based communication APA means is a set of architectural principles which we can design the web services as well. Okay, because at the end of we can develop the applications as we need to launch the application through the web. Okay, so in this cases we need the web services and the web APA, that is a web application programming interfaces. So that focus on the system resources and how the resource states are addressed, and also will be the transfer. Okay, how the resource states are addressed and the transferred. Okay, so then another thing is the REST APA. So the REST APA, it follows the request responses as well. Okay, it follows the request responses. In that one case, we have to use the architectural constraints. You got to use the architectural constraints applied to the component, or maybe applied to the connectors, or maybe applied to the data elements. Okay, so this is the diagrammatic representations. This is the diagrammatic representations of, or the figure shows there will be the client, HTTP client. That means a hypertext transfer protocol client, then the HTTP packet, then we have the HTTP servers, and also having the resources. Okay, so in that HTTP client, we have in the some of the protocols are used in HTTP client also. Okay, then the another model will be the WebSocket-based communication APA. So what is going to be the WebSocket-based communication APA? So this APA, it allows the bidirectional results, which means it will be full duplex communications between the client and the servers. So see the figure shows that there will be communications transferred between the client and the servers. So it will be sent as usual, we can be send this model, the WebSocket-based communication APA, it follows the exclusive pair model. It follows the exclusive pair communication model. So here you can see the client and server, so which means the client sends the request to the server. So based on the request from the client, it will be response to the servers, and we can send the data frames with us. So ultimate our aim is that we need to send the data frames, okay, between the client and the servers. Okay, so this is what we call as a WebSocket-based communication APA. Okay, so WebSocket APA, it allows the bidirectional and also allows the full duplex communications between the client and the servers. Okay, then the next model you have in the exclusive pair communication model, which we already discussed. Okay, so now we are going to see about what are the IoT levels of this. Okay, what are the IoT levels and the deployment templates of this. Okay, so what are the IoT levels and the deployment template. Okay, so for here the IoT systems, okay, the IoT systems, it has this some of the following component. Okay, the IoT system, it has this some of the following component. So the first components will be the devices as well. So the main component will be the device. Then the another thing is the resources. Then the another component will be the controller services. Okay, so another component will be the controller the services. Okay, so first of all, we should know about what is the devices. Okay, so the what is the device means? It allows the identifications there. The device allows the identifications and the remote sensing. So normally we have to do the remote sensing, and also the actuations, and we can do the remote monitoring capabilities as well. So we can use the different kind of IoT devices as well. While we are going to go through the next session with us, we can see what are the IoT devices are there. Okay. Then another thing is the resources. Okay, so the resources are the software component. Okay, resources are the software component, and the IoT devices for accessing. Okay, for we have to be accessing and the processing, also storing the sensor, okay, storing the sensor informations, and the controlling the actuators. Okay, and connected to the devices. Okay, so for here, what kind of the resources are we are using? Okay, what kind of the resources are we are using, that one. So the resources also include the software component. Okay, that enables the network access for the devices, and the controller devices. Okay, the controller devices is the native services that runs on the devices, and also it interacts with the web services. So this controller services will be sends the data from the devices to the web services, and this is the commands from the applications for the controlling the devices as well, for controlling the devices. So this is the some of the deployment templates. Then another thing is the database. Okay, so we need the, if you want to deploy any IoT applications, we need the main things, we need a database. Okay, so for in that databases, we have in the web services, and also the analysis component, and also having the application. Okay, so the database, it can be either, okay, the database can be either in the local, or we can be stored in the cloud. Okay, the data can be either in the local, we can store the data in the local, or we can be store the data in the cloud. And how we can be store the data means the data can be generated by the IoT devices as well. Okay, so after that we need the web services, because we need to be launch our IoT applications through the web orienters. So we need the, definitely we need the web services servers. So what is the use of that services means that link between the IoT applications and the database, and also analyze the component. Okay, then the web services. So these web services can be implemented. Okay, the web services can be implemented by using the HTTP, that's an hypertext transfer protocols, or it may be the REST principles. Okay, maybe the REST principles using the WebSocket protocols. Okay, then another thing is the analyze the component. So the analyze the component means this, we have to be responsible for to analyze the data. Okay, it's responsible for analyze the IoT data and generate the results. So we have to generate the results in the form of easy for the user to understand. Okay, then the another thing is the IoT applications. So the IoT applications, it provides an interface that the user can use to control and monitor the various aspects of the IoT systems. Okay, so for here, the applications allows, okay, the applications allow the user to view the system status and view the process the data. Okay, so this is the what we call as in the IoT levels and the deployment templates as this. Okay, so far we discussed of today lessons others. So what is the IoT and what are the characteristics of the IoT, how we design the IoT. So we can be design the IoT by using the logical designs and the physical designs. Okay, we can design with the IoT by the logical designs and the physical design. In that logical designs, we having the different communication model. So one is the IoT Function Block, the another one is the IoT Communication APA. Okay, then we have to be use the test and the WebSocket levels of that. Okay, so this is the today topics of this, which I covered the basics of Internet of Things of this. Okay, so thank you very much for your students and as well as the listeners. Okay, thank you so much. So in that next session of this, we're going to be see about that what are different levels of the IoT and what are the applications of the